Before we talk about compound inequalities and what that means, I first want to discuss this difference between an OR statement and an AND statement in mathematics. So the union of two sets, A and B, is the collection of elements belonging to A or B or both. When we use the statement A or B in mathematics, it means it's not one or the other. It means one or the other or both. And we denote the union of A and B as A union B with this union symbol. I always say U stands for union. Okay, so we will see the union symbol a lot as we look at interval notation. All right, and so I have a Venn diagram here, just to be really clear on this. When we say A or B or both, if I've got a circle of A and a circle of B and they're overlapping, the union is all of it, even the intersection of the two. Okay, so for example, if I had a set A equal to 1, 2, and 3, that's set, and B is the set of numbers 3, 4, and 5. Then if I had A union B, that would be equivalent to 1, 2, 3, 4, and 5, right? So I'm including all of the elements in both of the sets. 3 is included in both of them, but I'm only including it once in the union, right? But it's included in that. All right, now by contrast, the intersection of two sets A and B is the set of all elements that are common to both A and B. The AND statement has a special symbol too. So we denote the intersections of sets A and B as A intersect B, and this is sort of like an upside down U, okay? Incidentally, this symbol for the intersection is not going to be used in this class. We will use a special kind of AND statement, and it's important that you understand the difference between an AND and an OR statement, but we'll never encounter a scenario where that is used. So just to be clear on our Venn diagram, so when we're talking about the intersection of two statements, A and B, we want to know what's in the middle, okay? So hopefully that makes sense to you. With an OR statement in mathematics, you're including everything. With an AND statement, you're including just what they have in common. If I use the same example with sets A and B, A intersect B or A and B would just be 3, right? Because that's the only element that they have in common. So this is important because when we talk about what a compound inequality is, it involves an AND or an OR statement. So a compound inequality consists of two inequalities joined by the words AND or OR. And these are some examples. X plus 2 greater than -3 and x minus 3 less than or equal to 2 would be an example. X less than 4 or x plus 5 greater than or equal to 12. Both examples of compound inequalities. Some compound inequalities involving the word AND can be written as a three-part inequality, and that's the main type that we're going to look at here. So, for example, if you have x greater than 3, put it on the number line here. Here's 0, 1, 2, 3, 4, 5, 6, 7. So I have two statements here. I have x strictly greater than 3, and I have x less than 7. Okay, well, what do they have in common? This little piece right here, right, between 3 and 7. So we can rewrite that AND statement as 3 less than x less than 7. And you'll notice that all of the inequality symbols here are pointing towards the lesser number, right? They're all pointing towards the 3. And that's always the case in a three-part inequality. All of the inequality signs should be pointing in the same direction, and they should be pointing toward the least valued number. The least valued number might be over on the right, but it's often over on the left. So anyway, we'll be looking at that a little bit more as well.